Welcome to the 6th lesson of our Pinterest Money course. In the previous 2 lessons, we've been developing our Pinterest monster, and we've written 2 modules, the writer and the image generator. Today we'll finish what we started and write the 3rd module, Pinner, which will allow us to start uploading content to Pinterest, including not only images but also videos. So how can we develop such a bot? There are 3 main ways to do it: using HTTP requests, browser emulation, or the official API. In my Telegram channel, I talked about how to implement each of these methods, their advantages and disadvantages. In today's lesson, we'll implement 2 out of 3 methods. We'll write an uploader based on HTTP requests and one based on browser emulation. During the development of the uploader, we'll learn how to use reverse engineering when analyzing the operation of services and websites, intercepting and analyzing HTTP requests, forming and sending requests to the server using Python, analyzing responses and working with data in JSON format, managing sessions and cookies, and more. Today, we'll further enhance our object-oriented programming skills. We'll cover some of the principles that will help you start thinking architecturally and develop more flexible and scalable systems. Here's what we'll cover: working with multiple inheritance, understanding the method resolution order, learning about diamond inheritance, working with the composition pattern, understand how to choose between inheritance and composition, and learn to apply the single responsibility principle. We have a lot of work today, so let's not waste any time and get started. Let's kick off our development by installing the necessary dependencies. We'll need undetected Chroma driver, MoviePy, and Py3 Pinterest to get started. Open up your terminal and install these libraries using the following command. Next, within the modules package, let's create a file called pinner.py where we'll house the classes for our uploader. In this file, we'll define a class named PinnerBase, which will hold the common elements of our 2 uploaders. We'll inherit this class from the base Pinterest class. Then, we'll create the class for our first uploader, requestSpinner, and inherit from the PinnerBase class. Now we need to access the Pinterest class interface from Py3 Pinterest. How can we do this? There are 2 ways: inheritance or composition. With inheritance, we're already familiar. When using inheritance, your class inherits attributes and methods from the parent class. What is composition? When using composition, your class contains an object of another class as a component. This means that your class can use the methods and attributes of this object through its interface. How to choose between inheritance and composition? There are a few simple rules that can help make this choice. First of all, analyze the relationship between classes. If one class is a specialized type or subtype of another class, it indicates an inheritance relationship. On the other hand, if a class contains or consists of other objects, rather than being a type of them, it indicates a composition relationship. Next, we need to analyze the class with respect to the single responsibility principle. This principle states that a class should have only one reason to change. In other words, a class should perform a specific task and should not be overloaded with other functions unrelated to it. Let's reinforce this knowledge with practical examples. In our project, we've already used composition when writing the image generator. Take a look at the settings attribute of the base image generator class. This attribute is assigned an object of the template settings class. Thus, the base image generator class contains this object as a part through composition. Let's analyze why composition is chosen here. What relationship exists between the classes? In our case, the base image generator class is not settings or any specific type of settings, therefore it's not a subtype of the settings class. It simply uses its functionality. Thus, the has a relationship indicates the preference for using composition. Next, let's analyze the classes from the perspective of the single responsibility principle. The base image generator class is responsible for image generation functionality, while the settings class has its own responsibility. Different responsibilities indicate the preference for using composition. Let's now reconsider our requestSpinner class. We need to access the interface of the Pinterest class from the Py3 Pinterest package. Let's make a choice between inheritance and composition. Analyzing the relationship between classes. Here we face a dual interpretation. On one hand, the requestSpinner class is not a subtype of the Pinterest class. It should not inherit all the methods and attributes of the Pinterest class, but should simply use some of its functionality required for the uploader. In this case, The has a relationship suggests composition. On the other hand, we're not entirely satisfied with the current functionality of the API. We need to enhance its functionality, add logic for uploading video pins, and override some methods. In this case, the class that extends the functionality of the Pinterest class becomes a subtype of the Pinterest class, an extended version of it. In such a case, the is a relationship indicates inheritance. Next, let's analyze the responsibilities of the classes. The Pinterest class is responsible for the API functionality, while the requests pinner class is responsible for the uploader functionality. Different responsibilities suggest composition. If we inherit the requests pinner class from the Pinterest class, we mix responsibilities and violate the SRP. So what should we do? The best approach would be to create a separate class to extend the API functionality and inherit it from the Pinterest class. Then simply include an instance of this class as a component within the requests pinner class using composition. This way, we separate responsibilities between classes and maintain the has a relationship. The requests pinner class won't inherit all attributes and methods from the Pinterest class. It will only use the methods necessary for the uploader. Alternatively, we could inherit request pinner from Pinterest and directly extend the API functionality within the request pinner class, violating the single responsibility principle. Since the request pinner class already inherits from PinnerBase, in this case, we need to use multiple inheritance. Multiple inheritance is the ability for a class to inherit attributes and methods from multiple parent classes. Since we haven't covered multiple inheritance in the course yet, to learn it, we'll choose the second approach, knowingly violating the single responsibility principle. So let's apply the mechanism of multiple inheritance and inherit the requests pinner class from the second parent, the Pinterest class from the Pi3 Pinterest package. Please note that the name of this class coincides with the name of our base class, Pinterest. Therefore, we'll import this class with a different name. During the implementation of multiple inheritance, the diamond inheritance problem may arise. Diamond inheritance occurs when one class inherits from two classes, which in turn inherit from the same base class. This creates a diamond-shaped structure of dependencies between classes, which can lead to issues in resolving method calls and managing object states. Diamond inheritance can occur accidentally if you fail to track dependencies between classes, while diamond inheritance can be intentionally used to implement complex design patterns. In most cases, it's better to avoid it. In our case, we don't have an issue with diamond inheritance. Let's return to development. First, let's create the constructor of the PinnerBase class and accept the project folder as a parameter. Then, we'll call the constructor of the parent class Pinterest using the super function and pass this parameter to it. Next, let's create the constructor of the requests pinner class. What parameters should it accept? Primarily, it should accept the project folder and any parameters required to pass to the constructor of the Pi3 pin class. Additionally, we need to accept a couple of other parameters, the meaning of which you will understand later. So the parameter list will look like this. Now we need to call the constructors of the base classes. In multiple inheritance, there are different ways to achieve this depending on the inheritance hierarchy and the signatures of the base class constructors. To build the correct structure of calls to base class constructors in multiple inheritance, we need to understand the concept of method resolution order and use the magic attribute MRO. So, what is method resolution order? Method resolution order is the order in which the Python interpreter looks for methods in the class inheritance hierarchy. When a method is called on an instance of a class, the interpreter starts the search from the class of the instance and moves up the inheritance hierarchy until it finds the required method. MRO defines the linear order in which Python searches for methods. Classes are inherited from left to right, in the order they are listed in the class inheritance list. You can obtain the MRO list for a specific class using the magic attribute MRO. This list shows the order of method search from the class itself to its base classes. So what will be the method resolution order in our case? To see this, let's access the magic attribute MRO of the requests pinner class. We need to set up the launch logic for this. Let's do that. Let's run the bot. We can see that the MRO attribute returns a tuple that defines the method resolution order for this class and its parent classes. The Python interpreter will search for the attribute or method first in the request_pinner class, then in the pinner_base class, which stands first in the inheritance list. Next, in the Pinterest class, from which the pinner_base class is inherited. Then, in the py3pin class, which stands next in the inheritance list. Finally, in the built-in object class. In this order, we need to call the constructors of our base classes. Let's call the constructor of the first base class, pinner_base, by using the super function. When called without explicitly specifying the class, it automatically calls the constructor of the class that stands first in the inheritance list. Now we need to call the constructor of the second parent py3pin. To do this, we explicitly specify the class whose constructor we want to call. We pass the necessary arguments expected by the constructor. Note that when explicitly calling the constructor, we need to pass a reference to the current object as the first parameter self. When using the super function to call the constructor, this parameter is automatically passed. Let's take another look at the arguments we pass to the constructor of the py3pin class. We need to pass the proxy in the form of a dictionary, so let's write a method in the pinner_base class that will create this dictionary. Let's go back to the constructor of the requests_pinner class and call this method, and then save the result in a variable called formatted_proxy. Then assign the value of this variable to the keyword argument proxies to pass it to the constructor of the py3pin class. Alright, now let's create the attributes of the requests_pinner object and assign them the values of the passed variables. What do the attributes random boards and global link mean? To understand this, let's take a look at our uploading data manager. Here, for each pin, there are cells where you can specify the name or ID of the board, as well as the link. To avoid specifying this data for each pin in the account manager, we add the option to specify the board and link globally for all pins. Let's also create an attribute that will contain the path to the temporary files folder, where the thumbnails of our video pins will be processed. Also, let's place the format proxy method call after initializing the parent class pinner_base, because we placed the format proxy method in the pinner_base class. And by the time the constructor of py3pin is called, it should already be initialized. Alright, before we start writing the functionality for uploading video pins, let's take a look at the structure of the py3Pinterest codebase to understand what functionality we already have. In the constructor of the Pinterest class, attributes with account data are created, and instances of auxiliary classes such as Request Builder, Bookmark Manager, Request Session, and Registry are instantiated. These instances are used for making requests to Pinterest endpoints and managing authentication data and settings. Next, cookies are loaded from the storage registry and set in the request session. If the user agent is none, it sets it to the default value. Then come the methods. The request method makes an HTTP request to Pinterest endpoints using the specified GET or POST method, URL data, files, and additional headers. The method constructs request headers, including the custom user agent and CSRF token if available. The GET method makes an HTTP GET request to the specified URL using the request method. The POST method makes an HTTP POST request to the specified URL using the request method, accepting additional data, files, and headers if provided. Next, there are methods for logging into the account, working with boards, comments, pins, and repins, following, and much more. Let's proceed to extend the functionality of this class. The first thing we'll do is override the login method. Let's take a look at this method. Here, an instance of the Chrome WebDriver is created from the Selenium module, and browser options are set. Then the driver navigates to the Pinterest login page, waits for the email and password input fields to appear, then enters the credentials and logs in. After logging in, we retrieve cookies from the driver and set them in the session object, then update the cookie storage. What will we change in our overridden method? First, we'll use undetected Chrome driver. Also, we'll add a check so that the login method is only executed if the cookies file is missing. So let's get started. First, let's take the code for updating cookies and saving the session and move them to a separate method. To override the login method, we declare a method with the same name and signature as in the parent class. In the method, we'll check for the existence of the cookies file. If the file is not found, we'll log into the account, save the cookies, set them in the session, and update the cookie storage. First, let's generate the path to the cookies file that we'll be checking. Let's see how it's formed. It's formed in the registry class and consists of the folder for storing cookies and the account's email, which are passed as arguments to the registry class. Let's generate the file path in the base class Pinterbase. First, let's create an attribute that will contain the path to the folder for storing cookies. Then we'll form the path to the cookies file and assign it to the corresponding attribute. We'll accept the email parameter in the constructor and pass it from the constructor of the request's Pinter class. Also in the base class, we'll generate another path to the cookies file. We'll save cookies from the WebDriver to this file. Also in the Pinterbase class, let's add methods for checking the existence of the cookies file, for loading and saving cookies. Let's return to the login method. We'll add a check for the existence of the cookies file. Inside the check, we'll create a driver object. We'll pass user agent, proxy, and mode of operation to the method for setting up the driver, which we'll write now. Let's add a method for setting up the driver in the base class Pinterbase. Now let's create two class attributes and assign them the values for the login URL and the URL for pin upload. Next, let's return to the login method and open a try block. We'll set the wait, enter the credentials, and log in. Then we'll get and save the cookies, after which we'll call the method to set the cookie in the session and update the storage. All right, it's time to add functionality for uploading video pins. Before we delve into analyzing requests, let's clarify some terminology. What are GET and POST requests? GET and POST are two main HTTP request methods used for interacting with web servers. GET requests are used to retrieve data from a web server, while POST requests are used to send data to a web server. Parameters in a GET request are passed through the URL as a query string after the question mark. Parameters in a POST request are passed in the request body, allowing for larger amounts of data to be transferred. What tools do we need for analyzing requests? The main tool for this is the Browser Inspector. For a comprehensive analysis, I recommend installing the Burp Suite program as well. To analyze requests through the Browser Inspector, navigate to the Network tab, then the Fetch tab. Here we can start or stop recording requests, as well as clear the network log. Click on any request to see information about it. Here we see various tabs. The main sections we need are headers, payload, and response. Headers contain metadata about the request, such as the method, URL, content type, as well as information about cookies, user agent, and more. These headers are sent from the browser to the server and back. The payload contains the data sent with the request. For a POST request, this is the data passed in the request body. The response section contains the response body, which may contain data sent from the server back to the client, such as in JSON format. To analyze requests using the Burp Suite program, first launch the program. Then navigate to the Proxy tab, open your browser, proceed to the HTTP History tab, and perform the required actions within the browser. Click on a request to see information about it. Here you'll see the request data and the server's response. You can view the request headers, its query parameters for GET requests, and body parameters for POST requests. Let's start intercepting and analyzing requests. Let's begin. First, let's refer to the documentation of the official Pinterest API and see how pin uploading is carried out. First, you register an intent to upload a video. In the response, you will receive a media ID upload URL and a list of upload parameters. Next, upload the video file to the Pinterest Media Amazon Web Services bucket using a POST request to the upload URL provided in the previous step. In the body of the request, we need to set content type to multi-part form data and provide all of the upload parameters we received in the first step as key value pairs. In this step, you will also include the video file. A successful call will return a no content status code. Subsequent steps confirm the upload and create the pin. Let's manually perform the upload of a video pin and try to track the specified steps on intercepted requests. Let's upload a pin in the Chrome browser. Before dragging the file, let's open the browser inspector and switch to the Network tab. Additionally, for a more comprehensive analysis, let's perform the upload in the Burp Suite browser. To do this, go to the Proxy tab, open the browser, then switch to the HTTP History tab, and then perform the necessary actions in the browser. We will need the collected data later, but for now, let's return to the Chrome browser inspector. Now we need to determine the entry point. According to the documentation, it should be before the request to the Amazon server, which returns a no content status code in response. Now let's determine the exit point. It should be the first POST request, the body of which includes the pin's header, description, and board ID. Let's see what other data is needed for this request. The main data includes the tracking ID, video signature, and image signature. We will obtain these data from the server responses. Let's go back to the entry point. What data do we need to include in the body of this request? It's the ID and the duration of the video in milliseconds. We will obtain the duration of the video in milliseconds using the MoviePy library. Let's write a method for this. Here we will also get the width and height of the video. We will need this data for the body of the exit point request. Next, we need to get the ID. Let's copy this value and try to find it through search. We can find this value only in the body and response of the same request. This means we cannot retrieve this value directly. Let's try to generate it instead. Let's write a method for generating an ID with the same structure. Let's try to send the first request to register the intent to upload the video. We'll write a method for this. In the future, we will need to send the same intent for uploading cover images, so this method will handle all file upload intents. It will accept the following arguments. To send the request, we will use the post method. We need to pass the URL of the endpoint and a dictionary with the request body data. Let's go back to the inspector and copy the request URL from the data of our initial request. Then after the imports, we'll declare a constant and assign this value to it. The method will return the result of this request. Now we need to construct the data dictionary for the request. For this, let's copy the information from the payload and ask ChatGPT to construct a data dictionary for the post request. Let's copy the generated code. We see that the value of the data key is a dictionary. We need to convert it to a JSON string. To do this, we'll use the JSON dumps function, passing the value of the data key to it. This is necessary because the Pinterest API expects JSON format as the body of the post request. JSON dumps ensures correct encoding of special characters in the JSON string. We also need to substitute the variable with the ID here. We'll use string concatenation for this. Let's also add a check at the beginning of the method. Here we'll determine the value of the media info list variable depending on the mode. We'll copy this value from the dictionary and then simply substitute the variable into the dictionary. Also, we forgot to substitute the duration variable. Alright, now we are ready to send the first request. Let's create a public method for uploading video pin. This method will serve as a hub where we will sequentially call other methods. For now, this method will accept one argument, the path to the video file. First, let's get the duration, width, and height of the video file by calling the method we wrote earlier for this purpose. Next, let's generate an ID. Then let's call the method to register the intent to upload the video and pass the mode, ID and duration of the video as arguments. We'll store the result in a variable called response, and then print the JSON content of the response object obtained after the request is executed. Now let's call this method on our uploader object in the main py file and pass the file path to the method. Before calling the method to upload the pin, we need to log in to the account. We haven't logged into the account yet, and we don't have any saved cookies. Therefore, let's comment out the call to the method for uploading the pin for now and log in to the account. Before running the bot, we need to pass the account data to the constructor of the request pinner class. We'll connect the account manager later, but for now, let's create a dictionary with the account data. The keys of the dictionary will match the names of the keyword arguments expected in the class constructor. Let's fill the dictionary with the necessary account credentials. You can obtain the user agent from your browser settings or by searching for My User Agent on Google. Now let's unpack the dictionary into the constructor of the class using double asterisks. Let's run the bot. We encountered an error when creating the driver object. To fix this, we need to update undetected Chrome driver. To do this, go to the terminal and execute this command. Let's run it again. This time everything is fine, the login is successful, and cookies are saved. Let's uncomment the method call for pin upload and run it again. Excellent. We receive a JSON object in response to the request. Moving on, the next request we need to make is to upload the video file to the Amazon server. This request should return a no content status code. Here is the request. In the body of this request, we need to provide all of the upload parameters we received in the JSON response from the previous request. So we need to extract these parameters from this JSON response and create a dictionary with the data for the next request. Let's write this method. Now let's call it in our main method and pass the previous JSON response and the video ID. Now we need to create a method for uploading the video file. It will take the following parameters. First, we get the file name and its multimedia type. Next, we open the file for reading in binary mode and create a multi-part encoder object, which is used to construct form data, including the multimedia file and other data passed with it. We unpack the data passed in the argument into the fields dictionary and add a tuple representing the uploaded video file. Now let's see what headers we need to set for the request. We'll create a dictionary with these headers and retrieve the necessary values from the multi-part encoder object. These headers will be added to the headers formed in the request method of the Pinterest class. We'll also add an additional host header if the mode is set to video. Finally, we'll make a post request to the Pinterest server with the specified URL, form data, and configured headers. We'll copy the request URL from the inspector and assign it to the corresponding constant. Now let's call this method in our main method and pass the necessary arguments. The next request should verify that our media file has been successfully uploaded. This should be a GET request. Let's find this request in the browser inspector. Here it is. In the JSON response content of this request, there is a key called signature, the value of which we'll need for the final request of the exit point. Let's write a method for this request. First, let's examine the parameters sent in the request. These include the source URL parameter and the data parameter, which contains request options such as upload ID, The latter parameter is used to prevent request catching and typically contains a timestamp or another random identifier. To construct this request, we'll use the build-get method of the request builder class. This method requires passing the request URL a dictionary of request options and the source URL parameter. Let's declare a method to execute this request. It will take the upload IDA as an argument. Next, let's create a dictionary called options with the key upload ID and the corresponding value passed as an argument. Next, we'll create a variable called source URL and assign it the value of the respective request parameter. Then we'll construct the request URL using the build-get method of the request builder object, passing the necessary keyword arguments. Finally, we'll execute a GET request using the GET method, passing the request URL and return the JSON content of the response. Now, let's call this method in our main method. We need to obtain the value of upload ID to pass to this method. We can retrieve it from the value of the key in the JSON response of our first request. We extracted this value when forming the uploading data dictionary so we can get it from there. Let's run the bot and see what we get. Good, everything is working as expected. The file is successfully uploaded, and we receive a JSON response confirming this. So we already have some of the data needed to form the final request. We have the tracking ID stored in this variable. And we should have received the video signature from the response to the confirm uploading request. However, we encounter a problem. The response to the confirm uploading request doesn't contain the signature value. What can we do? Let's try searching for this value in the responses to the previous requests. We can't find anything. Let's try to search using Burp Suite. We find this value in the etag header of the response to the file upload request. Great, let's extract this value from there. All right, another value we need to complete the final request is the image signature. We can obtain it in response to uploading the cover image. The process for uploading an image is similar to uploading a video. First, we register an intent to upload the image, which returns upload parameters in response. Then we execute the upload request, from the response headers of which we obtain the image signature. Let's implement this. Let's start by finding the request that registers the intent to upload a cover image. Here is that request. It is placed before the request to upload the image, which returns a no content status code. We already have a method to make this request. We also have the data dictionary with the request body data. The only difference is the value of the media info list key. Let's form this value and substitute the values of the first and second ID here. Let's call the method in our main method. We'll generate two ID and pass them to the method. From the response to this request, we need to extract the upload parameters and form a dictionary with these parameters. We already have a method for this. Let's call this method in our main method. Now we need to make a request to upload an image. Here is the request. We already have a method for making such requests. The only difference is the URL of the request. Let's copy the URL of this request and assign it to the corresponding constant. Then we'll add this endpoint to the method. Next, we'll execute this request and then extract the image signature from the response header. Now, we need to get the image file. By default, Pinterest generates the cover image from the first frame of the video during upload. Let's do the same and write a method for it. We'll obtain the first frame image using the MoviePy library and save the image file in the project's temporary folder. Let's call this method in our main method and pass the file path and save folder path as arguments. After the image is uploaded, we'll delete the file from the folder. We'll write a method for that too. To execute the final request, we also need the value of canvas aspect ratio. Let's write a method to calculate this value. Now we're ready to make the final request. Let's declare a method for it. It will accept these arguments. Now let's copy the request body data and ask ChatGPT to generate a dictionary with the data for the post request body, just as we did before. Copy this code and add it to the method. Replace the necessary values with the corresponding variables and convert the value of the data key to a JSON string using JSON dumps. Next, we'll make the post request. Copy the request URL and assign it to the corresponding constant. Now let's call this method in our main method and pass the necessary arguments. Before executing the upload, let's add a small random delay between requests. We'll do this by adding a method to our base Pinterest class. Now let's run the bot and check the pin upload. Great, the upload is successful. Let's declare the main method of our uploader. It will accept such arguments. The first argument will be a list of dictionaries containing data for uploading. Let's leave the method empty for now and implement the formation of the uploading data list. The upload data is located in the uploading data CSV file. Let's add the logic of reading this file to the open CSV method, which is located in the base class Pinterest. Now let's go to the main PI file and implement the logic of running our uploader. We'll connect the account manager later. For now, let's just create an empty list called accounts. Then, we'll declare a for loop, inside of which we'll create an instance of the base class Pinterest. Then we'll read the uploading data file and save the result to a variable. Let's go back to the base class and declare another class attribute, assigning it the value of the uploader mode. Returning to the main PI file, let's check the upload mode. Inside the if statement, we'll create an instance of the requests pinner class, then call the login method, and then the upload method. We'll pass the uploading data list, the number of pins to upload, the shuffle mode, and the timeout to the method. Let's accept these arguments in the function, then move down and pass these arguments to the function. The launch logic is created. Let's move on to implementing the main method. First, let's add a check for the shuffle mode and shuffle the uploading data list using the shuffle method. Now we need to ensure that no more pins are uploaded than specified in the pins argument. To do this, we need to slice the uploading data list according to the value of the pins argument. We'll add a method called validate upload data for this. In this method, we check if the number of specified pins exceeds the size of the upload data list. If the number of specified pins is greater than the number of rows in the data list, the maximum possible number of pins is set to the number of rows in the data list. Next, we need to get a list of board data to obtain the ID of the required board. We'll use the board's all method from the Pi3 pin module. Now let's declare a for loop in which we'll iterate over each element of the uploading data list. Inside the loop, first we need to process and prepare the data intended for uploading. For this, we'll need to create another class called uploading data. In the constructor of this class, various object attributes are initialized based on the passed arguments. The truncate text method takes text and a maximum length and returns this text truncated to the specified maximum length if it exceeds this length. The prepare hashtags method prepares a list of hashtags based on keywords. It takes a string of hashtags separated by commas or spaces, formats each hashtag by capitalizing the first letter and adding a hashtag symbol if it's not already there, and then joins all the hashtags into one string. The prepare description method takes a description, a list of hashtags and maximum and minimum description lengths. It creates a new description that includes the past hashtags, truncating the description to the maximum length and adding hashtags afterward. If the description with hashtags exceeds the maximum length, it truncates the description to the minimum length and tries to add as many hashtags as possible to it within the maximum length. Now we need to create a method that will instantiate this class. Let's do this in the base class. This method returns an instance of the uploading data class with parameters taking values obtained from the dictionary passed in the data argument. For the pin link parameter, we assign the value global link if it's true. Otherwise, we take this value from the dictionary. For the board name parameter, we assign the value random board if it's true. Otherwise, we take the value from the dictionary. We'll add a separate method to split the string with random board names and choose a random board. Let's go back to our upload method and call the create uploading data method, passing in the necessary arguments. Now we'll be able to access the attributes of the uploading data object. Next, we need to get the board identifier. Note that we can specify the board in two formats, board ID or board name. So we need to check in which format the board is specified. We'll add a check to see if the board string contains only digits. If the string contains only digits, it means it's specified in ID format. Otherwise, we'll get the board ID by its name. Let's create a separate method for this. This method takes a list of boards and a board name string. It iterates over each board in the list and checks if the board name matches board name. If there's a match, it returns the identifier of that board. Next, we'll perform a check to see if the board identifier was successfully obtained. If not, we move on to the next iteration of the loop. Next, for each item, we check the type of the uploaded file. If it's a video file, we call the upload video pin method to upload the video pin, passing in the necessary arguments. Otherwise, the upload pin method is called to upload the image. We'll call the method for uploading images from the Py3 pin module. We'll enable the addition of emojis to the title and description. For this, we'll write a separate method prepare emoji. Emojis for each project will be stored in a TXT file called emojis, which we'll place in the project folder. We'll save several suitable emojis for the project theme, one per line. In the prepare emoji method, we'll read the contents of the file and split it into lines. If the list of emojis is not empty, a random emoji is selected from the list, which is then added to the input string. If the list is empty, the method returns the input string unchanged. Now let's add a delay after uploading each pin if it's not the last item to be uploaded. Also, after successfully uploading the pin, we need to move the data row from the uploading data CSV file to another file uploaded data CSV. Let's write a separate method for this, to which we'll pass the link to the uploaded file. In this method, we determine the paths to the input and output CSV files. Next, the process CSV method is called, in which data is moved from one file to another. The search for the required row occurs based on the cell containing the file path. In this line of code, it checks if the file path specified in the CSV row matches the path of the uploaded file. If it does, that CSV row contains information about the uploaded file and will be moved to another file. Otherwise, the rows are added to the rows to save list, which is then returned from the method. Next, this list is passed to the save CSV method, and these rows are written to the input file. After moving the data, the uploaded file is moved to another folder using the move uploaded file method. Let's construct the path to this folder and ensure its creation in the base class. With this, we can consider the main method of our uploader to be completed. To create boards, we'll need a CSV file named boards where we'll place the board data, including their names and descriptions. Let's create this file and then add an attribute to the base class with the name of this file. In the open CSV method, we'll add logic to form a dictionary with the data. Now let's declare a method for creating boards. It will take board data and a timeout value as arguments. In this method, we first retrieve the list of existing boards using the boards all method from the Py3 pin module. Then we extract the names of existing boards to avoid creating duplicates. Next, we declare an empty list called created boards, and then iterate through the elements of the boards data list in a loop. Now we need to create a separate class to handle board data. In this class, we create two object attributes and assign them the values of the board name and description, trimmed to the maximum length using the truncate text method. Then for each element in the loop, we create a board data object containing the name and description of the board. Next, we check if a board with the same name already exists. Next, we try to create a board using the createBoard method from the Py3 pin module. If the board is successfully created, we retrieve its name and ID from the JSON response to the request and add a dictionary with this data to the list of created boards. Then, we make a random delay between board creations. Finally, we return the list of created board data. Now let's create the logic to run this method in the main PI file. We'll create a function called creating boards. We'll connect the account manager later. For now, let's create an empty list called accounts. For each account, we'll create an instance of the base class Pinterest, then read the board data using the OpenCSV method. Next, we'll create an instance of the requestPinner class, call the login method, and then the createBoards method. We'll save the result in a variable. Next, we need to write the board data to a CSV file. To do this, we'll iterate through each item in the list of created boards. For each item, we'll call the writeCSV method and pass the data row and the file name as arguments. Now let's refine the writeCSV method. We see that the header and order lists are the same, so we can remove the redundant element. Let's create a header list for each file, which will serve as both the header and the order. We just need to return to the main PI file and add a call to the creating boards function to the entry point. To test the bot's functionality, we just need to connect the account manager. Let's create a separate file for the account manager and define the account manager class in it. This class doesn't depend on the specific project folder, so it won't inherit other classes and will remain independent. In the constructor of the class, we'll create an object attribute and assign it the path to the account's CSV file. Next, we'll define a method to determine the CSV file delimiter, and then we'll declare a method to read account data from the file. In this method, we'll open the file for reading createReader object, and for each row where the value of the first cell is 1, we'll form a dictionary with the account data and add it to the list. Finally, we'll return the list from the method. Now in the main PY file, let's add the creation of an account manager object and the call of the getAccounts method. Let's add another mode to our pinner, which operates by emulating a browser using Selenium. I'll add the class code and briefly explain how it works. So in the class constructor, object attributes are created based on the passed arguments. Also, an attribute containing the browser object is created. Next, methods for waiting for elements are declared. Then a login method is declared, where the existence of a cookies file is checked. If the file exists, the cookies are loaded into the browser, and the login process happens automatically. If not, manual login is performed. Next, a method for pin upload is declared, which serves as a hub where individual methods for dragging the video, entering the title and description, and selecting the board are executed sequentially. Finally, the main method is declared, where pins are uploaded sequentially based on the uploading data list. Let's add this mode of operation to the base class. Now we'll add the creation of an instance of this class in the main PI file. Before testing our bot's functionality, let's add the option to choose the operating mode using input at the entry point. Now create a file named account.csv and place it in the data folder. Fill the file with account data. To start processing an account, enter 1 in the first cell. First, let's create boards on the account. To do this, create a file named boards.csv in the project folder and fill it with the data of the boards you want to create. Now let's run the bot in the desired mode and see how it performs. Great, the boards are being created. Let's check if the data of the created boards has been saved in the table. Now let's test the bot in upload mode. First, let's copy the data of the boards. We can specify the board for uploading in the uploading data file. We can specify the board name or its ID. To avoid specifying boards in the uploading data file, we can set the boards globally in the account's CSV file. We can specify multiple boards, and then one of them will be randomly chosen. Let's set the boards in the accounts file, specifying the board in name format. Also, let's globally set the link for our pins. Let's go back to the uploading data file. The links to images generated by our generator are filled in automatically in this file. We need to manually add links to videos. Let's do that. Also, pay attention to the texts generated by our writer. Review the table before uploading and replace any incorrect values. Now let's save the table and test the bot in upload mode. Alright, everything is working smoothly. To work with multiple accounts, create and prepare separate projects, and then activate the accounts in the accounts file. Congratulations! With that, we can consider the development of our Pinterest monster complete. Before assigning homework for this lesson, I would like to emphasize one point regarding working with videos. Now let's move on to today's homework. That's all for today. We have completed the main part of the course and finished developing our Pinterest monster, which you can already use to automate your work on Pinterest. But that's not all. Now we are faced with the question of how to scale correctly and take our work to the pro level. We will discuss this in the final part of our marathon. See you in the next video.